Welcome to my YouTube channel Raise a Cat. Myself Yash Mishra, and today in the solution thermodynamics we will study what is Roults law. This is very important concept in solution thermodynamics. So let's see what is Roults law. Solution thermodynamics. Okay. So if a liquid phase is an ideal gas solution, then the equilibrium partial pressure of species I at the system temperature is equal to the product of mole fraction of species I to the vapor phase of species I. So this is the definition of Roults law. So let's understand what it states. So suppose that this is the partial pressure of species I is equal to xi into saturation pressure of species I. So Pi is equal to xi into Pi sat. Okay, so this is the formula. So this is the partial pressure of species I into mole fraction and liquid phase into saturation pressure. Okay, so the partial pressure of species I at system temperature is equal to product of mole fraction of species I to vapor phase of species I. Okay, in the pure form. Okay, so we know that the total pressure is equal to the summation of the partial pressure. Okay, so suppose that the partial pressure of there are two species. The partial pressure of first species I is 2 and second species having 4. So the total combined pressure will be 6. So the total pressure is equal to the sum of the partial pressure of the species which are present. Okay, so and we know that the Pi is equal to the Pi is nothing else but the pressure in the vapor phase. Okay, so Pi is equal to Yi into P, and P is nothing but the total pressure and the Yi is the mole fraction in the vapor phase. Okay, so this is equal to Pi. Pi is equal to Yi into P. Okay, so the value of Pi now becomes Yi into P is equal to Xi into Pi sat. Okay, so Yi is the mole fraction in the vapor phase, Xi in the mole fraction in the liquid phase, P is the total pressure, Pi sat is the saturation vapor pressure. Okay, so this we deduced from the Roults law. Okay, so this is the definition which we have to remember from the Roults law, and these are the two concepts which are used, that the partial pressure in the vapor phase of any species I is equal to the mole fraction into the total pressure. This is the normal definition which we know. If we want to find the partial pressure, we will just multiply it by the mole fraction of it, then we will be able to find the partial pressure. This we know, and this we know that the total pressure is equal to the summation of the partial pressure. These two things we know, and this thing is reduced from this, that the Pi is equal to the Xi into Pi sat. Pi is the partial pressure and the Pi sat is the saturation vapor pressure, is equal to the into the this mole fraction in the liquid phase. So mole fraction in the liquid phase and vapor phase, and how this total pressure and saturation pressure are related, we can derive from this. Okay, so and this mole fraction in the liquid phase and the vapor phase are both are of the same species. Suppose that benzene and toluene or some other solvent CCl4 or some other are present, so they are of the same species. Xi and Yi are of the same species. Okay, and the Pi sat is also of the same species, and this P is the total pressure of both the species which are present. Okay, so this is the concept of the Roults law. So let's take one question. Suppose that the vapor phase mole fraction of benzene is 1/2 mole fraction in the vapor phase. In the liquid phase, it has a mole fraction of 1/2/3. Okay, in the mole fraction in the liquid phase. Okay, and the total pressure is given as 5 atm. Okay, so we have to find the saturation vapor pressure. Okay, so what we will do, 1/2 into this total vapor pressure in the vapor phase. What is the mole fraction in the total pressure is equal to 2/3 into the we have to find the saturation pressure. Okay, so 5/2 is equal to 2/3 into pi set. Okay, so 15/4 pi set. Okay, so is equal to the 3.7. Okay, so this is the pressure at in saturation vapor pressure. We found it 3.7 atm. So this was the concept of the Roults law, which we used to find this saturation vapor pressure. Okay, so this we can use to find this mole fraction in the liquid and vapor phase also, or the total pressure which is present. Thank you.